you can say hi to. Oh, okay, Sarah and Boston. I think everyone is here. Just slowly make yourself comfortable. Move the external. Connect to the common server. Go to the right directory. Please let me know when you are in the right directories. If you need assistance in getting there. Ready? Sure. Huh? Yes, yes, yes. And it is not mandatory but recommended that you open specific directory for each lab. Make directory LAB5
Okay.
to the movements with the organized. Okay, I'll start chatting. I'm done or close to done. So here, here is the list of subjects that we cover that you feel make a list of presentations that we will select on Friday and we'll get prepared.
This Friday we have presentation?
No, at earliest next Friday, but I'll check if it matches the lecture material. No, I believe you need at least 1 weekend before presentation to focus on present. Again, it will be same format. Last time we did a little overtime. We used the whole 2 hours. So we'll try to be shorter this time. So the presentations will cover the basic use of God's new software, and to match the class material, we will focus on the use of particle field. The subjects for today are shown in red, and the stuff that we did last time, I believe it is here, right? So this part is covered. We will cover this, and in the third slide before presentation, I'll cover whatever is missing. Yes.
No, sir. In the last class, I remember that we covered total energy, but ionization energy, and definitely gas. So how to calculate this?
So the energy of frontier orbitals approximately correspond to ionization and activity. The support energy of LABs occupied in first time. Okay. So just to start slowly. Last time, and after we have done this this material, we make sure that everyone is comfortable. Maybe we'll answer questions or help with the homework. So to slowly remember what it was and begin the model of determinants for hydroxyl groups found the electronic structure in a single point, which means total energy and energy of each orbital. And now we have 2 challenges. Well, it's not deep, it's easy practical challenges. First, how we should keep going in defining molecular orbitals and floating them in space as 3-dimensional bubble. Let me show right away. So we will generate images like this one, right? So here is the model of that we're using for study, the deterministic site, right? And here are the bubbles for one of the molecular orbitals that localize simultaneously on several atoms. It was challenge 1. Challenge 2, we found that for this small molecule, we have a couple of dozen orbitals, right? But if you take something of practical size, number of orbitals will be huge. And it will be a little hard for us as humans to browse through the list of orbitals, find the right one, and analyze them. So we need something, a way to translate list of energies of orbitals into something that will look homogeneous, will look in a similar way, no matter what is the size of our model. So this will be the images like this that we discussed at the end of what we read. The name of this object is density of states, and it shows occupied orbitals on one side, unoccupied on the other side, and in a space where there are no more those is called band gap in physics, and in different communities there is a little different name, but this style of images is quite universal. So the one movement is to get practical skills how to make these two figures if I oversimplify. Right? Of course, number of orbitals that one needs for analysis of the model is bigger than one. One needs two or maybe more orbitals. Like one orbital represents one peak in this one. The one I was showing corresponds to the occupied, but I want to see on the unoccupied and a few more. Okay. I did send you two, well, I sent maybe more than needed, but I did send you two Word documents from the previous year.
Yeah.
And the first one, which is called LAB5 -2, which doesn't mean 3, maybe it's second version, includes on the, starting from the bottom of the first page, the list of suggested commands. The most important command that we will be practicing is here, but one needs all of them. So total like 4 commands. So do not rush the systems. We will very quickly. With the soul, and I'm sure that everyone feels comfortable being oh, so here is the plan, and I will be very happy to discuss ideas and theory behind it, but we need to quickly go over practical and make sure that we are done in a reasonable time. So well, first tell my works, and then make sure that we'll be able to together. So we'll start from this density of states, because it just can be done in 4 commands. The orbitals are done in 2 commands. Let's start with all of the complicated stuff. And we are not going to run actual calculations. We will use the output files that were generated in the previous step. So what I tried to do for exercises for the day just before the class, I did copy the output files .log and .chk in the new directory so that it doesn't look garbage. So it's not cool. And then we are going to practice this command. So what is being done? And maybe I'll give you words more, but this is more theoretical background rather than practical things. So I'm going to draw something on the blackboard. Or decide otherwise it will develop. So suppose we have energy, and we do have orbitals starting from lower energy and going to higher. Then we'll have a region where there are low states and then states orbitals being energy supported. Right? So we need to draw something on the y-axis. Right? And the plan is to associate each state with a function that has area equals 1. Right? So, and we will take the width of this function close to 0. So if we associate such little peaks to each energy where we have an orbital, then we will have such figure. Make sense? So why it is done? Why I do not do just sticks? Because if we do have a situation when states are placed closer to each other, then one peak and another peak and another peak will overlap. We will add them together and they will bring bigger stuff, or maybe something more complicated. So no matter how close states are to each other, it will be always one figure, one line. So the definition for this thing is shown on the equation here. So we put delta function, which means our function is centered at energy. Depends on energy, and here energy sub I is specific energy of one orbit. There is another definition that you may have seen in statistical mechanics and thermodynamics. So the axis will have density of states, and another definition that I'm not going to use, and will not invite you to use it here, is number of states per energy interval, which means how many states are localized for the energy interval delta E. Like if there are many states, it will be taller. If there are fewer states, it will be lower. Right? But this is more theoretical when one obtains energies by equations. If you compute them by computer, the definition of this summation of orbitals is more appropriate. Okay, I think it is enough. Now I'm going to practical demonstration. And if you have an idea of what to do and have energy, you can go ahead and do things earlier than I do. But I'll slowly show and then shuttle between tables and ask those who are online to share their screens. So here is my manual. and I need to practice these four commands. I'm going to the move extern, and since I already did some practice, it's too many files, but I will copy the log file that I generated just into a new name. And for next 10 minutes, I will work with this file, test.log. So this is the file that we all have generated at the end of the previous meeting. So if you look inside, you recognize there is a list of occupied and virtual orbitals, right? And it is what we are going to focus at. Okay. So I'm going to back to my menu and just copy this command. Copy and paste. So the file name .log should be the output of the Gaussian, the file that we need to analyze. The parameters here are as follows. I need to refocus on the board. So first number 1000 is how many grid points, how many points are used to represent this line. So if I want to represent a curve with in a digital form, I need several grid points, right? Then next number, 0.01, is the width. So for individual peak, what will be the width of this function in electron volts? And the numbers 5, 5 at the end are how far below the HOMO and how far away from LUMO. So we show most interesting region of the gap, and we show several orbitals plus minus 5 electron volts before and after. When you will be doing it yourself, you're very welcome to experiment with this parameter and see what will change if you use different input parameters. So so after I execute this command, there appears 4 new files. Before we go forward, I would like to look inside. So more E underscore O C. You recognize this table, right? So it is a list of energies of all orbitals, of all occupied orbitals. If you put more E virtual, it will show energies of all empty, unoccupied orbitals. And if we look through this file, then some practical work is already done. So the energies are converted from atomic units, from Hartley to electron volts, and they are arranged in the columns instead of table, so that it is more comfortable. So first column is index of orbital. Third column is energy in the Hartley. You see the HOMO and the LUMO are minus 0.5 and 0, right? You recognize? And here are the same numbers converted in 12 volts. So minus 13 something and around 0. The number here shows how many electrons are placed in a given orbital. So for orbitals that are occupied, we have 2 electrons per orbital, right? For those which are unoccupied, there are 0 electrons. Maybe before we go forward, let's try to do this analysis. Okay? Please try. And we'll do some graphical exercise at the second part of today's meeting, so you will not regret that you came here in person. This part can be done remotely, but the graphical part will need your ready. We open the file with the shop. What? Word file, yes. Open board. Because we charge it. Yeah. We need to copy this through, copy this through to the end of the line. Okay. There are police replacements. Then we just right. So same as the
But last number 4, we have number 4 and that is 4. And that is last 4. How to make it last 5?
or work yes. Lina, would you like to share your screen?
Dr. Khan, I had an issue with.
And your microphone is muted if you're telling something.
Yeah, the old file has
maybe
the name. It's disabled.
Should I stop sharing our screen first? Not yet.
Not yet.
Oh, I need to give permission. Sorry. Sorry. Make co-host. Yes, and Steven make co-host. Yeah, sorry, I forgot about it. Yeah.
So it says I wrote the command here, but I think I had an issue with the file name because I had spaces here. I don't know how to deal with that. I tried many times, but it gave me this.
Okay, type Control C just to stop it. Control C. Stop it. And now do CP space. Start typing beginning of the file name. Titanium underscore TI uppercase TI. And now hit the tab button. Hit the tab button. Tab. It is
okay. Okay.
To the left from the letter.
Yeah, but I. Okay, so it's TI.
If you hit tab button, it will automatically it should automatically continue.
Tab. Okay.
Okay, yeah, then maybe put one more underscore. Letter B to show by hand B, just letter B. And now tab once again. Now tab push type log log space test, just write test
Okay.
.log. Enter.
Enter.
Okay. Now just do ls minus lt to see what are your files. Space minus lt. So you see the test log has the same size as your titanium by hand energy HF. It's like 16 kilobytes, right?
Mhm.
So now just practice the command that you were trying with test.log because it is the same file. So please push arrow up
This. And
and then arrow left and replace this long name. Yeah, and remove the letter Z.
okay.
Enter. And now do ls minus lt to see what you have. Enter. And do more space E underscore energy letter E capital underscore
E
uppercase
capital.
underscore T test uppercase test. The name of the test dot log dot not comma but dot.
Oh, sorry.
Test dot log. Enter. So and you can hit enter a couple of times to scroll.
Yeah.
So you see occupied and unoccupied, right?
Okay, so yeah, from here we have the occupied. Yeah, thanks, Doctor.
Oh, my pleasure, my pleasure. Yeah, thank you. Steven, would you like to share your screen?
I will stop share now.
Steven, would you like to share your screen to share to show?
Yes, just a minute.
Okay.
And so I was copying over the command when I had to go do something. So it's.
And it can be painful to type. Just copy paste from the Word. It could be quicker. If you did download this the file, show all attachments, and we need the file that is named LAB5-2. Yes, this one. And maybe yeah, if you can, the whole thing until the end of the line. It will be much quicker. Yeah, yeah. Copy. Go here. Remove everything and try to paste. Okay, and now you need to use arrow left to remove the caret at the very beginning of the line. Remove. Yes. Now arrow right to the file name, to the middle of this record. Again, left, and replace the file name with the actual name of whatever you like. TIO4H4, and hit and now remove one period. Just backspace once. Enter. Hit enter, and now try ls minus lt. Space ls space minus lt. Now once again ls space minus lt. Okay, so you see this four files that were created last, right?
Yeah.
So please try to type more space E underscore uppercase E underscore, and then this TIO4 enter. So the meaning of this file is that it has the same energies of orbitals as computed by Gaussian, and column number 2 is atomic units, and 3 atomic units, and column number 2 is electron volts. So if you look on the energies of orbital 24 and 25, it will be HOMO and LUMO. Do you see it?
Yes.
Okay, yeah, thank you. You can stop sharing. we all are on the same page. So, yes. Oh, 5 is special. 5 is oh, Linux creates so I will go forward momentarily, but just in case before. So this little script is I was involved in developing it, but it is not something of the top secret. So if you will try to practice this procedure on other computer or under other account, you need to copy the script. It's not like feature of all Linux computers or all Gaussian. You need to copy it. And if you look inside, you see it's just a little script that parses and looks through the file and extracts correct sentences with the word with a keyword grab. Just we do not need it for the class, but if you have curiosity and you want to be independent and run it on other computers, just you need to copy. So it's not very long. It's maybe like about less than 200 lines, a little more. But if you are not interested in programming or running on a different account, you can skip it or talk to me later. Now, let's go further through our menu. So I'm going to the next command, copy, and here you see that there is one more file, DOS, and ends with O, which is good, but it is too long of the file name. So I want to copy this file that I have created into the file that is named dos.log, so that it will be more standard. So I copy the file that I just created into dos.log, and if you see this little line here, that is our target density of states. It should be two columns, one that lists energies and another the height, how high the density of state is, right? And number of points here should be substantially bigger than number of orbitals. So we agreed that it will be 1000 by the parameters that we used. So this information about this line is already created and stored in this file that we just renamed. I'm going to return back to sharing screen. So if I'm not looking inside this long file before, because it is, let me count. You see, it has 84 kilobytes, which is a little too much for a human. And it has several columns, and first column gives this very small step goes over energy axis, and columns 2 and 3 just show the heights of the density state. So if you like Microsoft Excel or microfile origin, you can just download and put this file. But basically, this stuff is already computed, and the formula that converts discrete energies of orbitals into continuous density of states is already done in one script. But what I'm going to show right now with next two commands is how to plot graphics if you do not have license for Microsoft Excel, or if you hate Microsoft Excel, to be a little bit more independent. Because drawing of the figures is quite a standard thing that was existing way before Microsoft was developed as a company. So I'm going to the menu and look for the next thing. Copy, paste. So it's GNU plot and then name of the script. So GNU plot is a specific program to make graphics, and the GNU means it is free for everyone. Instead of drawing things on a screen with a script, it just creates a file with graphical information. So after executing this command, I do ls -t, and I see there is a new file, dos_go9.ps. PS is ancient format for graphical files. Today we typically use PDF, and there is, if I look next into the manual, there is a command that converts PS to PDF. So I can copy or just type it. So PS number 2 is abbreviation for the word to, PDF, and then WR for write. Then I give this name of the DOS_Go9.ps. I hit enter, and then I check what are my files. And you see, after .ps, there is a new file, DOS_Go9.pdf. Okay. Then I'm going to the right panel, navigating to correct subdirectory, and observe that this file here. And then I just double click or drag and drop and bring it to computer and see this image. Okay, so please practice these steps, and I'll go around the class once again. So if I was too quick in showing the commands, you can just look into this manual LAB5-2.
Like it's solar to you now. And then we will
Oh, sure. Yes. For the work. Yes. Oh. Oh, you wrote the those for the youth of the children. It's great. That's very good too.
okay, next time I will.
Good. Winner, would you like to share the screen?
Yes. I think the name of my, so I have to use the my file again. So
For the future, try to avoid spaces in the names.
Yeah, sure, I will.
Okay, now let's just erase this line, or type Control C to start new line. Just Control C.
Okay.
Okay. Please do ls. Okay, so you do have a file. You have file dos_w period 01 underscore test.log. I think it is a good file. Now I just let's see what we're taking. No. Did you open the manual, the file LAB5-2 from the email?
Oh, not this.
Please do it. There is nothing smart there, but it will just speed up the process.
LAB5 too?
Mm-hmm. And you see we are about done with the first part.
I had an issue with my screen. I don't know what.
It doesn't show in your shared screen because you are sharing only one window. You can stop sharing and start over to share your whole display if you do not have secrets. Well, sometimes there are secrets like.
I don't know what happened with my screen in the laptop. It's it has an issue.
Just start sharing screen. When you type share screen, it will give the options to share specific application for the whole screen.
Okay.
Okay. If it doesn't work, do not worry. Just open this Word file for yourself and identify the manual. So it's at the
here.
And I do not see it, but I believe you'll find it. So it's last lines of the first page and few lines on the top of the second page. I can even copy those.
Okay. I will just share with the.
Let me copy everything into the chat line just in case.
Okay.
Oh, now I see it. Yeah, excellent. So you see the 2B, at the very top of the second page.
Here? CPO, okay.
Yeah, okay. Now let's go to the command line in MobXterm.
I see, can you see, Doctor, the...
No, I do not see your MobXterm, but you can go there. Okay. And now use arrow, yes, and remove things here. Okay, then move, stop, back, arrow left. So put left, one more, put 0. Now right, several times, and replace the file name, right.
Okay.
Or then backspace, and now type test, uppercase. And now hit enter.
I think here there is no 0. Okay. Yeah.
Further. Just in case, as a little experiment, do ls -ot to see that dos.log is not empty. Minus log, enter, and scroll up. So you see file dos.log has like 84 kilobytes.
Okay,
Right?
yeah.
So it's good. Now look to the menu for the next record, and you do not need to show it to us. I
Okay,
do
yeah.
you'll find it. So
Yeah,
the
I need
next
to use GNU block.
yes,
Okay.
copy and paste this this line.
Mm-hmm. Yeah.
Yep. Enter. Now type ls minus lt. Enter. And scroll up a little. Yeah, you see this dos underscore go9.ps.
Yeah.
Now let's look at the menu for the last command
Okay.
that tells ps
These
to
two.
pdf and copy paste it.
Okay.
Enter. Now, do you know how to?
Yeah.
Yes, exactly. Yes. Find the file sftp. No. Wait.
Oh, what am I doing here?
Slowly.
Okay.
Do not click anything.
Okay.
Do not click anything. We are under control. Slowly move your mouse down more slowly.
Where?
Down. Not down. Not so quick. Now slowly up. Now slowly to the left. To the left.
Left.
To the left.
Okay.
Down. Click. SFTP, which is secure file transfer. Now up, slowly up. Find the green stuff. Double click. Scroll up this panel. Scroll up. Double click green stuff. Now scroll down. Find Scratch 001. Double click. Find CHEM676. Double click.
And then here.
21. Double click. Find your yes. LAB5. 4. Okay. And now double click on this.
Yeah,
yes.
this. Okay. Ooh, finally.
And can you please show, stop sharing and start sharing the right panel?
Okay, I will show now the PDF file.
Okay, perfect. Yeah, thank you. Thank you for sharing.
Thanks, Doctor.
Super. So you can stop sharing.
Okay.
Steven, would you like to share your screen? Steven, if you're interested to share your screen. Thank you.
I tried to do the new prog, and it gave me this error message.
But can you open up the manual, the Word file? It will be just quicker if you open it. Yes. So scroll down. First line at the second page. No. Scroll up a little more. Yeah. The automatic parsing. Wait. Second from the bottom on the first page. CP DOS. Yes. Copy. Paste. Now arrow left, several times. And now backspace, just erase everything. Erase. Stop. Now type DOS. Type OK. No, it should be uppercase DOS. Try to hit tab button. No?
No.
Underscore. Tab. No. Okay. Let's do Control C. Just Control C. Stop this line. do ls minus ot, ls space minus ot, enter. So we need, okay, now type cp space dos underscore w underscore period 01 underscore, and you see the pattern. Just keep typing the file name. Okay. Yes, and now type dos.log. So you just rename .log. Enter. Not cd, cp, copy. Copy. Enter. Okay. And now let's GNU plot. Type GNU plot space tilde slash bin slash GNU prog underscore dos underscore gauss. Enter. ls minus ot. Enter. You see the last created file is dos underscore go9.ps, right?
Mhm.
Okay, now type convert it into PDF. PS to PDF. WR space dos underscore go9.ps. Yes, enter. And now you need to download this, do ls minus ot once again. You see there is a file that ends with PDF, right?
Mhm.
So you need to download it to your local computer if you use WinSCP or something else. But if you use MobaXterm, it is like integrated terminal and file transfer. Maybe you use different software to transfer files, but please download this PDF file to your desktop.
Right. I am using WinSCP, so I can do that.
Please do. I want to see the file. Yeah, a little over time, but do not worry. It's enough time. It's enough time to do everything. So Stephen, are you going to share?
Just a second, Professor.
Yep. You can open WinSCP, share WinSCP window, and you'll browse. We scroll through together. It could be quicker if you want to.
It's downloading now.
Mhm.
Should. It's not showing up.
Just double click on those on this PDF file we just read. Maybe it will be sufficient to download.
So There it is.
Yeah. Okay, very good. Yeah, I think everyone is a certified expert in these two states. You can stop sharing. Yeah, thank you. So now our goal is to create image like this. And I believe it's most pleasant part of the course, at least for me. if I need to take it once again. Next 40 minutes, we will be doing it together. So, when you run Gaussian, you create the input file name, which is like myfile.home, right? After Gaussian is done, it generates at least two output files, one .log, which we just analyzed, and another .chk. So the file .chk contains orbitals and many other information that is sometimes not needed, sometimes yes, and it is in not user-friendly format. So we need just some steps to extract this image from the file. So this procedure is done in 3 steps. First step is so-called formatting. I'll show the commands in a minute. Second, generating the file for this image, which is called cube file. And the word cube, because this model is placed in the cube, the rectangular cube shape where all grid points are defined. And the third, actually opening this file in Gaussian. So let's find a manual. It's not a big challenge, but with manual it's a little quicker. So please open file with name graduate research Gaussian spin orbitals. And there are 2 commands that we need to repeat. I highlighted them in the right. Form check and cube gen. Or we are opening the bless you. Graded research Gaussian LSD this one file. And we are going to practice these 2 commands in red. So I can copy paste the first one and go to my command line. So first I want to make sure where is my .chk. So I can use in the long format, or I can rename it if I like, if I want, but I'll just use in this format. So I type here, I paste the prompt from the manual, and I replace the word job name into the name of the file. So in my case, it is titanium O blah 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 CHK. So I paste the name of this file into here. And now it's better just to avoid confuse to use the same names for input and output, so they differ only by file extension. So, and then for most reasonable files, it is done quite quick. Sometimes it gives an error. Just do not be surprised or confused if you do big models or if there are some problematic optimization. It may refuse to do it, but for small models, it should be fine. After this command, I do ls -lt. And I do see that there is a new file named fchk, right? Chk. I'll visit you. This is just simple command. I'll visit you and do everything at once. So I see that there are some questions. So open manual, and we practice only these two commands. So it's so it is about line 1, 2, 3, 4, 5, about 15 lines from the top. Form check, and I can copy. Just in case, I can copy it into chat line if you need. So after I'm done with this command, I need to go to the second one.
So you change the file name here for MC then title then again you wrote something.
Here is the command that I practiced. So first form check space, then name of the file that ends with chk, and then the same name but with fchk, and then enter. And after this, I copy paste the second command from the manual, and I type or copy paste cube gen space o space mo24, and here I need to place literally the name of the file that ends with fchk, and then space mo24 cube. Then I hit enter. So this operation may take a few seconds. And after this operation, type -LT. I see there is a new file named mo24 cube, and you see it is relatively big. So it is 6 megabytes, or even 7 megabytes. So it's much bigger than anything else you created before. In about a week from now, I explain why it is so big. But briefly, the check and form check contain only expansion coefficients in front of atomic orbitals, and molecular orbital files contain point-by-point values of wave function at each point of space. That's more information. Why did I use MO equal 24? Huh? That was going to be my question. Oh, yeah, sure. So let me bring up once again the file dos.log. So more dos.log. No, wrong one, sorry. LOG is this one. E underscore in the name of the file. So the file that we did look at about half an hour before. So you see orbital number 25 is the last occupied. So just from physical intuition, frontier orbitals, last occupied and first unoccupied, contain most important information because both chemistry and optical activity happens near the band gap region and conductivity as well, right? So 24 is a good example to start with. Next example to explore will be 25 because it is first unoccupied. But if you are doing experimental work and you just need to add a little computational component to your thesis or to your paper, you can stop at this meeting and do anything else in the class. So adding this density states and orbitals is a legitimate information that you can insert into publication. It contains a lot of insight about properties of materials involved. So you already are like partially ready for independent work. You can generate this orbitals for more of your choice, plot it, put the image into the paper and describe how you interpret it. And it has a chance to be competitive. So I'll do the last step and then I'll make a look over this. Did you answer the question 124? And if you need more orbitals, you can just change name of the cube file and change the number of orbitals. MO stands for molecular orbital. I can immediately do 25. 25. 1, 2, 3, 4, 5, 6, 7. Okay, about 10 seconds. Now I am going to the Gauss view and opening the file. Open. For me personally, it is boring to do 24 because I just did it in before. Let me do 25. So I here, instead of input or output, I scroll through file type and select cube files. Otherwise, if I select different format, it will not be seen anything. Then I select the one that I want, open, and it shows only the model. Right? But do not panic, it's normal. So it shows only the model, but information about the orbital is already there. It is downloaded. Now, in the main Gaussian menu, I go to results and select surfaces contours. And here is the window that I need to focus on. So it shows molecular orbital number 25, number of points 80, 80, 80. It means it chops the whole universe around the molecule space, around 80 grid points in each direction. So it's like total 5, 12, 0, 0, 0, like 500,000 of grid points, right? 80 by 80 by 80. That give the value of wave function in each point of space. So the information is there. Now we need to plot so-called isosurface. And it will be my next demonstration on the blackboard, the concept, but let's do practical things. So surface action, new surface. Click. And it appears here. And I'll make a tour over and make sure everyone can do it. But right away, let me show something. If you plot both occupied and unoccupied, you will see the differences. So this one that I'm rotating right now is occupied. And you see these balloons are localized on the red spheres, right? Red spheres correspond to oxygen, and these balloons have green and red areas, which stands for plus and minus. And they look like little dumbbells. So it is p orbitals of the oxygen. Right? And those are occupied because oxygen is oxidizer, it pulls everything. Unoccupied is in majority, not 100%, but most, is localized on the titanium. And you see this donut shape, right? Which is a d orbital. So empty orbital has d character, and it is empty because oxygen has stolen electron from titanium, right? So if we are going to practice affinity, it means we will be populating this orbital in the titanium, right? You place electron there. If you want to borrow an electron from this molecule, we need to take it from aggressive oxygen that probably is not happy to give anything. But affinity and ionization. So it's time now for me to make a tour, and if time remains until 7, I'll make explanation what is iso value, which is quite simple and natural thing, but I can give a little explanation what is this number.
Doctor,
Yes?
Dr. Khan, how we get this window to show these orbitals again? So, how to get this window, cubes available, cubes interactions.
Okay, I understand. So in main Gaussian window, you see,
okay, yeah.
Results, surfaces, contours. Okay, and then this cubes available will pop up.
Okay.
Okay.
Yeah, thanks.
So I'm going to make a tour around seats and make sure that everyone can generate these images. Seems good. Okay, good. Now let's copy from the the whole thing. So, okay. And the previous more correlate. Sorry. Drawings. To keep change to documents without understanding the work. Change this number totally would be good. Maybe 0.02, maybe 0.04. Satisfaction. Go back to the same thing that we can do. Not the one contemporary. Yes. Sacrifice to your time and first. If you already here into university, after your university, start doing more of the homework. I'll do the same. Yes. I'll try that. Change this number to something a little bit. Okay. This number. I just know that you can show. Yeah, you don't have 27. Let me tell something which something about the work of graduate students in computational chemistry. So, I know that graduate students in continent are the root of the globe in the intellectual strength and power. But by the matter of fact, the PIs, recruiters, unfortunately, hire or take graduate students in their group, not only for thinking, but primarily for making Deutsch work. Right? It doesn't surprise us. And in wet chemistry labs, Deutsch work is like wash the test tubes and make synthesis. Right? In computational case, one of the reason for doing so-called Deutsch work is because the recruiter knows how to do things, but just has only 2 hands instead of like 8 or 200. And one needs help in doing a lot of simple work. And type of this regular George work in computational chemistry, one, for example, is floating orbitals. Because suppose your boss your group wants to watch the orbitals of the folder that we studied, you can provide him with the .chk file. You can find them all yourself. Okay? You just go, but it's a little ridiculous because he or she needs time for other activities. And it is kind of responsibility of the students to prepare visual information for analysis. And what quite often activity that various students use time for going regularly for 20 orbitals one motion and 20 orbitals for another and putting them into PowerPoint or Word. And then later on together with the project they look on this create orbitals and analyze them. I know it's not the best situation in the world, but it happens very frequently. And if you just if you're already in competition with any of your friends, so that such pattern of activity will not look as a surprise. Because I understand, I was a graduate student myself, I understand the ambition and the truth that the brains in the earlier ages are much brighter. Unfortunately, it's opposite. The decayed brains in the later years are used to think, and brighter brains in the early years are used to do later work. But I want to change how the world is arranged by probably some in my ideas. So sorry for this little thing, and let me ask first Win and then Steven to share their screen. And Win, would you like to share screen?
Yes, sure.
Oh, thank you. Okay. Oh, I see you have created this cube file. Yeah, very good.
But when I apply to...
Just click enter so that I see how it responds to your command. Okay, and for the practice, you can arrow up and replace 24 to 25. No, not scroll. Just scroll down.
Okay, but I wanted to ask, so I need to use this file here, right?
The one that you have created. Let's scroll down. Scroll down to the end. And can you please just push arrow up a couple of times, and I will see which commands more. Arrow up.
Okay.
Arrow up. Arrow up. Stop. No. Another step. Arrow up. Stop. Arrow up. Arrow up. Arrow up. Arrow up. I want to see your form check command. Just click up until I see how you practice form check.
So first I copied the one that you provided.
Yeah, I understand. But can you need to, did you generate form check file yourself or you copied it? Oh, stop. It is what I needed. It is what I needed. Can you click arrow left, and more, arrow left, and now backspace. Just make the file name shorter. Yeah, start backspace to remove stuff. Backspace. Okay, enough. Enter. ls-lt. Scroll. And if you don't like scrolling, you can do vertical line and head. So you see among the last created files, you have this form check file. which is good. But I think what you did is, let's check. Let's maybe practice cube gen once again. Just arrow up to save space 2 times. Oh, you want to type cube gen? Type at the beginning. Yes. And now, replace this one by the one that you just created. L, type letter, space. L.
I have to type name here, right?
Yes, letter L, and then hit tab, it will automatically continue. Okay, enter. Good. And maybe just as an Kaya did ask us to put orbital 27. Let's put arrow up. Okay. Now change number 4 to something different.
This 4?
Yeah, 20. Put 27, for example. And then at the end also do. No, wait. Oh,
sorry.
Wait until. So here, if it is here 27, at the end of the line, it should be 27 as well. Otherwise, it will be a big mess, and you will it will work. Hit enter. Just hit enter. If you give different names for orbitals, it is a good thing to decept a spy, but will not help to your work. And let's redo 24 once again, because you may arrow up, enter. And now do ls minus lt head. ls space minus lt vertical line. Okay. So we have this 24 and 27. Now let's go to Gauss view. Gauss view, main control window. Oh, you need.
I need to
stop sharing. And then for us share. Do not share anything. Go to Gauss view.
Okay.
Open file. Select the file type cube, and open this mo24.cube. And share the window that shows the model.
Yes.
Okay, now go to the, do not share, do not do anything slowly. Refocus by clicking to the main control panel of Gaussian, not for us, but for yourself. And select their results. And in the results, find surfaces contours. So in surfaces contours, yes, surface action. Bring back the surfaces contours.
Action.
Surface action, yes. Surface action.
Got it.
And it's a new surface.
Okay. I can just show you what I got. This.
Super. Yes. And you see this bubbles, these balloons are a little bit large, right?
Yeah.
So you can go to this menu for surfaces and contours, go to surface action, and make the remove or hide surface. Yes. You can, yes. And now you see there is a MO equals 0.02. Replace this number 2 to 8.
8 to 8?
8, yes. And now surface action,
Mhm.
new surface, new surface, new surface.
New surface.
And now you see it's a little bit more beautiful.
Yeah.
So the general trend is the larger the isosurface value, the smaller are balloons. Okay? You can stop sharing.
Okay. Thanks, doctor.
Thank you. Steven, would you like to share your screen?
Professor, you need to add me as a host again.
Yes. Okay. I did. You should be able to share.
And so the command is cube gen MO, and then any number really.
24. But in between CubeGen and MO, I think it should be letter O that stands for orbital, because CubeGen may generate some other cubes as well. We just do not have time today. Lowercase o here. Not 0, O, yes. MO equals 24. Space. And then copy the name or type the name of the form check file that you have created. And do Control C. If you're not Control C, arrow up, and space, type mo24.cube. Enter. Now let's go to Gauss U. If you are using Gauss U from Photon and you have X term, you just open it. If you have Gauss U on your desktop, then you need to download this cube to your local computer.
Or just share the entire screen.
In this given CPU, may download this molecular orbital 24 to your local computer. These contours. Okay, excellent. Yeah, thank you much. So I think everyone is ready, and so here is where we are. I probably need to make a comment about isosurfaces either now or during the lectures, but very briefly, the larger the value of isosurfaces, more compact are balloons. I probably can do it in one. So suppose we have one-dimensional function. But suppose I am not a human. I am just a worm that can see only in one dimension, either to see right in front of me or not to see. Then, for point of view of worm, it can be some function is seen or not seen, right? So we need just to select the heights and then explore the points that select areas above and areas below. It's not the end of the story. Now, suppose that we have a two-dimensional function. So we have x and y. And it is some beautiful function with several peaks, several points. Okay. Now, suppose that I'm two-dimensional creature that cannot look on this x, y, three, like even the function is two-dimensional, the image is three-dimensional, right? So if my eyes and brains are two-dimensional, I can only select the height value and dissect this two-dimensional object with a surface. And then I'll find contour lines where the function is higher than this threshold or lower than threshold, right? So from two-dimensional function, I go to efficient one-dimensional lines. Okay? Now, if I have three-dimensional distribution f of x, y, and z, I can dissect it in three-dimensional space by the values where function is equals to either value. And then if I do the same operation in three-dimensional space, instead of continuously distributed function in any point of space, I will get balloons, contour lines, contour surfaces. So I will go from three-dimensional function to efficiently two-dimensional surfaces, right? So the surfaces is what we do when we plot orbitals. So orbitals exist far and close, but we show only like surface of a balloon, because our to show this fully represent this function, we need 4 dimensions that our brain and eyes do not help to identify. Right? Okay, I think we are done with everything. I'll stay here to answer any questions, but if you need to depart, if you are in rush for other activities, I'm not holding you. We are done in time, and wishing you good evening. And if you need to depart or disconnect, it is okay. Yes. You want to what?
Yeah, thanks, Dr. Kalan.
I want to show you something.
Yeah, thank you, Lina.
Bye.
Thank you, Professor. See you next week.
Stephen, you were telling something?
I'll just thank you. I'll see you next week.
Oh yeah, see you. And you're welcome. Yeah. Yes. Mm-hmm. If you remove the element that you remove, because this chemical is needed to remove, and what can be equal? If you want to bring in the So if you use different model, the number of occupied and unoccupied will be but still it's standard with the okay, what's that? This is conversation. This one, okay. The energies of no, it's fine. The energies of so if no one is online, I'll probably stop recording